Good morning, everyone. So welcome to my YouTube channel, Maths Spectrum. So today we are going to see third lecture of group automorphism. Okay. So let's start today's session now. So I recall the definition of a order of an element in a group. Okay. Let G be a group and A belongs to G. Okay. Then the order of A in G is smallest natural number and such that a to the power n is equal to e. E means identity. Okay. So what is the meaning of a to the power? Note that a to the power n means a into a up to an. We are operating a n times. Okay. We are operating a n times. So dot is the operation in a group. Okay. Okay. So remark. Okay. Remark. If no such natural number n exists, then the element A is said to be of order 0. Okay. Order 0. If no such element exists for A such that A to the power n is equal to E, then the order of A is called 0. Okay. Okay. We denote the order of A by order A. We denote this symbol. O means order. We are taking order of A. Okay. Third one is that note if M is a natural number such that A to the power M is equal to E, then order of A always divides M. Okay. It means there exists another natural number K belongs to, there exists another natural number K. There exists register a natural number k such that m is equal to k times order of a. Okay, this is coming. Now we know that. So what will happen in this case? Suppose a divides order of m. Okay, in this case, m is equal to k times order of a. Okay, but k is greater than 1 because k belongs to natural number. A natural number always starts from 1 to 3. So least natural number is 1. So if I put 1 in place of this, so this will be less than equal to, but this is order of a. So this implies m is always greater than order of a. Okay. In this case. Second note is that if f g to g is a homomorphism, okay, then identity always maps to identity. Okay. And inverse of the element is always inverse of image. It maps inverse to inverse of the image. Okay. And last one is that you take any a to the power n here, a to the power m here. What is this? This is always okay. This is always s a to the power m. Okay. For m belongs to integer. Okay. Integer. We can take minus power here also. So it will map to minus power. Okay. A natural number as well. Okay. So one thing. Third remark I am writing here. Okay. A to the power 0 means what? A to the power 0 means identity. Okay. A to the power 0 means identity. Always. We take this notation. A to the power 0 is always identity. We will take. So now we prove a result for theorem, you can see. Let G be a group. Let G be a group. and F and automorphism of G automorphism of G if A belongs to G is of order greater than 0, then prove that that order of FA, image of A is equal to order of A. Okay. Let's prove it. Let order of A is equal to n and order of FA is equal to m. Okay. So first, since order of A is equal to n, we have what we have A to the power n is equal to E. So this implies I can operate both the sides automorphism F. Okay. I can operate both the side or automorphism F. But I already told this is nothing but F A to the power n. Because you take any natural number here, it will become this one. And what is this? It will be mapped to identity. Okay. So now I already told that this is element. FA is now element in G. And raising the power m is equal to E. What does it mean? Imply? That it implies that m is greater than equal to order of FA. Because we can use this fact here. I already told that if m is a natural number set and a to the power m, then order is always less than that number. Now FK you consider element FK. Okay. Now same thing you apply here. Okay. Here. Now next. Order of FK is equal to m. So we get, what is the definition of order? Fa raised to the power m. Sorry, here there is n. There is n. Okay. I wrote. So you write here n. So n is less than equal. Now order of FA is m. So we get what is the definition of order? You operate FA m times, you will get identity. But again we can write this. This implies Fa to the power m, we can write it. And this is identity. Okay. but E can be written as F E. Okay. So what we have? This implies F A to the power M is equal to F E. But F is 1, 1. We get inside thing will be equal. So this implies what? The order of A M will be greater than order of A. Okay. So in equation number first, what meaning of equation number first? You write one line here. What is the N? N is order of A. So order of A is greater than equal to order of FA. So that is equation number 1. Okay. From here, what we get? What is M? M is order of FA. So this implies order of FA is greater than order of A. So from 1 and 2, we have, from 1 what we have? From 1 what we have? Order of A is greater than order of FA. And by equation 2 what we have? Order of FA is greater than order of A. Order of A is greater than order of FA and order of FA is greater than order of A. What does it mean? This implies both the order has to be equal. So order of FA is equal to order of A. So this is proved. Okay. So this is proved now. Okay. So what is the definition of a subgroup? What is the definition of a subgroup? Subgroup. Subgroup of a group. Let G be a group. Let G star be a group. Okay. A non-empty subset H of G is said to be subgroup of group G if H with same operation star is a group. Okay. Now we have this result. Note that let G star be a group, then a non-empty subset H of G is subgroup okay. So that write it here and let G be a group. Okay, G be a group and H be a non-empty subset of G. Then H is subgroup of G if and only if and only A star B inverse belongs to H for all A and B belongs to H. So H is subgroup of G if this condition holds. If this condition holds for all A, B belongs to H, then H is subgroup. Okay. So now we are going to prove, do one example. Example. Let G be a group. Okay. G be a group. H a subgroup of G okay, comma F is an automorphism of G. Okay. Let F H, the image of F under H, image of H under F, that is nothing but F H. Okay. H belongs to, small h belongs to capital. Prove that H is a subgroup of G. If you take any subgroup, the image of H under an automorphism also a subgroup. We need to prove it. Okay? Let's see its proof. Okay. So let A and B belongs to FH. Okay. Then there exists H1, H2 belongs to H such that A is equal to F H1 and B belongs to F H2. Okay. Since H is subgroup of G, we have H1, H2 inverse, it belongs to H. Okay. Okay. Now, what is this? Now, what is AB inverse? AB inverse is, okay, 1 minute. Let me. Now, now, what is the, now, H1, H2 inverse belongs to H. So this implies F, H1, H2 inverse will belongs to FH. Okay, FH. So what is this? By property of homomorphism. Because automorphism is an homomorphism. Okay. But inverse will come out FH1, FH2 inverse. Okay. So now what is this? FH is A and FH2 is B. So A inverse belongs to FH. Okay. For all AB belongs to FH implies AB inverse belongs to FH. So this implies FH is subgroup of G. Okay. FH is subgroup of G. Okay. So it is done. Okay. Now next one. What is normal subgroup? What is normal subgroup? Normal subgroup of a group G. Let G star be a group. Then a subgroup N of G is said to be normal if said to be normal if N star said to be normal if G star and G inverse belongs to N for all N belongs to N, capital N, and G belongs to G. Okay. Okay. So this is the definition of normal subgroup. So we are going to prove a result. Okay. Example. Let let G be a group. F an automorphism of G. Okay. F is automorphism of G and a normal subgroup of G. Okay. Prove that F n is a normal subgroup of G. Let's prove it. Okay. Okay. So N is normal subgroup of G. Implies N is subgroup of G. Okay. Subgroup of G. Okay. Okay. N is subgroup of G and G and G inverse belongs to N for all N belongs to N and G belongs to G. Okay. G belongs to G. Since N is subgroup of G, by previous example we get Fn is subgroup of G. In previous example, we have shown that if H is subgroup, then image is also, it means Fn is also subgroup. Here N is subgroup, so Fn will be subgroup. Okay. Now let K belongs to, small k belongs to Fn and X belongs to and G belongs to capital T. Okay. So K belongs to Fn. implies there exists. This is symbol of there exists. N belongs to N such that K is Fn. Okay. Now, what is this? G F. What is this? G. Okay. Okay. Now G belongs to G. Okay. But this implies there exists G dash. So here you take G dash belongs to G and G dash belongs to G means there exists G belongs to G such that G dash is equal to Fg. Okay. Why this is happening? Because F G to G is onto. If a map is onto, you take element G dash from G. There will be another element G belongs to G such that G dash is equal to F. This is property of onto. Because F is automorphism. Automorphism is onto map. Okay. Now G dash K G dash inverse. What is this? You write these values. This is Fg and this is Fn and this is Fg inverse. Okay. So what I can write this? Fg Fn and it can be written as this is this. So by property of homomorphism, all these things will be inside. I can write like that. Okay. Okay. So where it belongs? This belongs to Fn because G and G inverse belongs to N for all N belongs to N and G belongs to G. Okay. And these things because G belongs to capital G. Okay. G belongs to capital G and N belongs to small n. Sorry, small n belongs to capital N. Okay. So that is why this is belongs to this. So this implies G dash K G dash inverse belongs to Fn for all K belongs to N, K belongs to Fn, K belongs to Fn and G dash belongs to G. So this implies, okay. So this implies Fn is normal. Okay. Sorry. Now what we have? What we have actually? Finally, we have Fn is subgroup of G and G dash K, G dash inverse belongs to Fn for all K belongs to Fn and G dash belongs to G. We get that Fn is normal subgroup of G. So Fn is normal subgroup. So image of a normal subgroup under a automorphism is a normal subgroup. Okay. So this is done. So today's lecture up to this. In this lecture, we have studied what is the order, and order of an element is preserved by automorphism of a group. Similarly, subgroups and normal subgroups are also preserved by automorphism. Okay, they will remain normal subgroups. Okay. So today's lecture up to this. If you have any problem related to this, you can comment on my YouTube channel. Like, share, comment, and subscribe my YouTube channel. Thank you very much for today's lecture.